In this video tutorial and Grasshopper tutorial, I'm going to show you how you can make a waffle structure from a solid. So first I'm going to make the solid, and then I'm going to show you how we can make this waffle structure and use a technique to make the two-way slits on the solid, and then you can just simply make that if for your own. You can just simply use a CNC or a laser cut file to produce the results and just set it up. So basically we're going to talk about the waffle structure, how we can just change the number of the we're going to talk about how many sections we need in the height and in the length. We can also change the thickness here, so we're going to talk about the thickness, and we also will at the end have the curves out this. You can see that I just have the output of the curves, and then you can just make that and have a CNC machine or a laser cut to make the waffle structure. So basically this tutorial will be talking about I will show you how you can use a two-way slit waffle structure in Grasshopper. Okay, to start from scratch, I'm going to draw a rectangular surface here in Rhino. So I'm going to have this here. Then we can just copy and paste it, Control C, Control V, and move this one up. Okay, and now I'm going to rebuild this surface and easily have a soft edit surface. Move here, and we can just deform the surface with the soft edit surface tool, and here we go. Okay, then I'm going to choose both of these surfaces and use the duplicate border tool to have the border. Okay, and now I'm going to connect these two borders together with the loft surface, a loft tool, and then okay, and now we can just connect all these three surfaces together with the join. And let's just turn this up. Okay, I'm going to move this to the corner 0, and now we want to make the waffle structure from this model. So I'm going to first import this into Grasshopper as a brep, and let's just set this. Okay, and what I'm going to do is to connect a box to this. So this box will help us to define the direction we want to make the sections from this model. So this will be first direction and this will be the second direction. So then we can just have a deconstruct brep here and have the edges. So now we can just pick this with list item, and the edge number 0 will be this one. Okay, so now we need the sections to the first direction, and then we make that for the second, and then we can make the waffle structure come out. So I'm going to use the contour tool here, and you can see it here. You can find it also in the intersect, mathematical, and the contour tool. I'm going to use this as the shape. The starting point will be, okay, we need another list item here and pick the vertex. Okay, the first vertex will be the point of start. The direction will be exactly this direction, or we can also use the X direction. So I'm going to give this an X direction. And the distance is, we can simply divide the length of this line into the number we need. So I'm going to connect a number to this, and we will have the length of the line. So if we divide this into the math and division, let's divide this by 12. We will have exactly 12 section. But for being always right, because sometimes you can see that some of the contour sections will not come up exactly like at the corners. I'm going to slightly decrease the distance. So I'm going to right click an expression and say x minus 0.1, and this will allow me to always have the section at the end. So you can just have maybe 0.01, so it just gets them to the near. Okay, so the next one will be for the z direction, so I can just have another list item here, and let's just find the height of the box. Okay, here we have it, 8. So this will help us with the length again, so I'm going to use another number division to find the length of the sections in the z direction, and now I'm going to use another contour. The point will be exactly that point we started here. The direction will be the z direction, and here we go, we have the length here. Okay, so we can have this 8 by 8, and we're good to go. Now we can just start this. Okay, first of all, we don't need the, okay, we have a problem here perhaps. You can see that the section is not coming up from here. So we can simply just move this point. Okay, we used here, let me see, we had the vertex, the starting point of the z direction, and I'm going to slightly move it up. So we can also have, to be sure we don't have problems with the sections, so I'm going to move this point in the z direction and just a little bit, and give this as the starting point, and you can see that it will just be okay, and we have the end. Okay, so now we need to delete these sections. We don't need this one, we don't need this one, we don't also need this section and the last section in the x direction. So what we can do here is use the col index tool, and it just deletes the number we need. So I'm going to use a technique here, and you can always use this to delete the first and the last. So first we can just delete the first section, and if you check this out, you can see that we have 9 curves here. So I'm going to first of all flatten this, because if I just give the index 0 to this, you can see that all of the curves are gone and we have nothing here, and that is because it will just delete the first index of the first group and there will be nothing, and the first in the next group till the end. So remember, we need to flatten to have all the data in one group, so we can just delete the first one. So if you don't know what about the flatten and the graph inputs and outputs, feel free to check the video we talked about the in the question part, in your questions, number 1. Okay, so we just flatten this and delete this 0. Now again, we just copy paste this, and what we will do here is just right click and reverse the data. So this is the technique you can always use to delete the first and the end. So let me show you. You can see that the first and the end section has been deleted, and that is because we first delete the list, the index number 0, and then this will be just the 0, 1, 2 to end. Okay, then we just reverse this. So when we reverse this, this will be the 0, 1, then we will have 1 till the end, and then we delete the 0 here again. So this technique will just delete the first and the last data you need to, with simply using the col index with a reverse in the output. So we can just copy and paste this and use this for the next sections. Okay, and remember to flatten the data, and here we go. Okay, now I'm going to, let's just turn this off. Okay, and now we need to find the intersection between these two curves. So what I'm going to do here is I'm going to, let's extrude this. Okay, we can have a thickness of maybe 2.5. We need a thickness here. So I'm going to move this. I'm going to explain that. If we need a thickness of 2.5, first we have to move this back by minus 2.5 divided by 2, and then we can extrude this totally by 2.5. So you can use this technique to make an extrusion and put the section at the center of the extrusion. So I'm going to move this in the x direction and give the factor an expression minus x divided by 2, and then I'm going to simply connect the surface to this and extrude that in the x direction, and now I'm going to give it completely 2.5. So you can see that the extrusion will make the be exactly at the center of this, and you can also use this technique to have another one for here, and we're going to use a z direction here, so perhaps this will be a z. We have exactly the same thickness here, so let's just type this as a thickness and have this minus x divided by 2, and now we can just give this the whole complete 2.5 in the z direction and have these at the center. Okay, so we have two sets of solids here, and what we're going to do is to find the intersection between these two ones and make a box on this. So I'm going to make a bounding box on the intersection and move this. If we have the length, we can move this at the half of the length back and subtract this from this and move this half of the length towards the front and delete this from this set of solids. So let's do this in Grasshopper. We're going to go to the intersect, and we can use the brep tool, and let's just have the intersection. Okay, what will happen here is that the first one will be calculated with the first set of the solids, the second will be the second, and the third will be with the third. So what I'm going to use to have all the intersections here, you can see we just have a flat intersection based on the first, the second, and the third. So we're going to use a cross reference here, and we can use the cross reference to make everything go and connect to each other. So a cross reference tool, I will make a tutorial about cross reference, but for now it will make all of the possibilities between the intersections of these two solids, and here we have them. Okay, now we're going to have a set of curves. We can go to the bounding box in the surface tool and connect these. Okay, and there's a point here. If I just bake this box, you can see that sometimes it's okay. We can find this if it has a problem. Okay, you can see that there's two sets of box here, and that is because when we want a box from these intersections, it has two sets of intersections. So this is the first set of intersection and the second one is here. So it will make two sets of box, one for this and one for that. So we can easily fix this by right-clicking on the bounding box and using a union box to be sure we have a union box in the groups. And here we have this. You can see that we have all the box, a simple and a single box for each of the intersections. Okay, so now we have to move these boxes backwards. I'm going to, okay, we can just flatten this so we have all the boxes, 49 boxes in one group, and you can see them here, and the groups doesn't matter. So now we can just go and deconstruct again these boxes and use the list item to extract an edge here, So this is the first edge. We need the length here, so I'm going to give this a number. Okay, we will be lucky if we had the 5. Okay, you can see that the 5 is the length of the box, and if we connect a curve here, we can see that it's just happening. Okay, and now we can just move this, and let's just move this box in the X direction, or the Y direction. I think it's the Y direction, backwards. Okay, I think that we don't need the flatten here because all the data will be in one group. So if you even flatten, you have to fix this with another graph here, and I will explain that further. Okay, so let's get back. If you just hit and take that flatten off, it will be okay. But if you just flatten this, I'm going to explain what we should do. So it's just going to be an exercise on the groups. Okay, let's go back and assume that we just accidentally have used flatten here. Okay, so now we have the lengths of these boxes, and we have to move them in the Y direction, but at the half of the length. So I'm going to just divide this by 2 and give this. Okay, look what happens, and that is because of the groups. The first input is not in groups, and the second is in groups, and that is because the first is just being flattened. So we can just fix this with grafting this input, or you can simply just take out the flatten here, and everything will be okay because all of the inputs are just into groups, and the inputs will just be exactly for each group. So you can see that I have moved this about half of the length. We can just have this in another direction, and that will be minus y, so it's going to be minus x here. So just go forward, and now we can have two sets of boxes, so we can just take these off from the solid. So I'm going to go to the intersection and use the solid difference, and that will be the end. So I'm going to make a difference between this extrusion, and for a tip, always flatten all the inputs, because Grasshopper will just calculate the B-reps or the solids which have a difference or have an intersection. So I'm going to give this to the first set of solids, and let's just flatten all of these, and we need a difference between the next one and this. Okay, and that's finished. Now we can simply bake this in the first layer and bake this in the second layer, and you're good to go. You can see that we have the waffle structure, and let's just move this backwards so we can see this. Okay, so that's it. Now you can simply make this by giving this a number. So let's just do this. Okay, I'm going to have another deconstruct B-rep on this, and let's just make the first face off. The first face maybe is the usually it's the biggest one. You can see it here, and we just use this again for the next set of curves and the solids, and here we have this. So you can see how easily we just made this work. Now we can connect a curve to this and connect the curve to this one, and we just extract the boundary so we can make it and use it for a CNC machine or for a laser cut file. So you can see easily how I just made this. You can just orient these on the surface easily. I'm going to show you how you're going to make you can simply do that with Rhino if you want. You can go to the transform, orient, and use the 3 points. This will be the first and then second direction, and then I'm going to give this the first and second direction. So you can easily orient this on the surface. I'm going to make this a full video in the Grasshopper course, so how you can use plugins and easily put them on the ground and make them in numbers, but that's okay. You can see that we have the results, and it's just a matter of time. You can easily produce the results. Okay, let's just turn this off, turn this on. You can see how simply I can just change the thickness. Okay, I can change the number we want. We can just change this to maybe 5 and to 5 sections. And we can also simply deform this by cage edit. I'm going to deform this. Okay, and let's just check this out. We can move this forward. Okay, and I'm just trying to show you that you can use this technique for whatever you want. Okay, turn this off, and you can see that this will just be an update for that. So this tutorial, you just learned how to make a waffle structure based on a solid. Remember, you have to have a solid structure, have a solid model, so you can easily take out the box and go to this. I'm going to put this example in my website so you can download this, and then we will have okay, let's just bake them. You can see that you can make the structure simply by this step-by-step tutorial and have them in sections. And we can also have the curves easily by using a deconstruct erep, and here we go. So this was the most simple way you can use the box, but we can have this in many different ways. Just let me just show you. Okay, we can make this in another direction maybe and have another sections. We can just have this in a curve situation. I'm going to explain these in advanced Grasshopper tutorials in the course, so stay tuned and check the course in the website. But for now, you can see how simply we can just have the output easily on the model and make this with the thickness we want. We can simply just change the thickness. Okay, we had this thickness thing here. You can just set this to 1, and you can see that the thickness will just change. Okay, and here we go. We can just maybe bake this solid difference so you can see the result. Okay, thank you for watching, and comment underneath this video what you think about it, and if you have any questions, feel free to ask, and subscribe to the channel. Hit the bell button so you can just get informed about new video tutorials. And thank you for subscribing to the Parametric House website and our YouTube channel. We will just upload daily Grasshopper tutorials in our channel, so be sure to subscribe. Thank you.